Right, hello everyone. My name is Timothy Lee Grant. Welcome back to another engineering investigation video. And these series, what we do is just try to look at different concepts within engineering, some things that I stumble upon during my day-to-day that I'm not quite understanding or that I'm trying to investigate further to be able to get a better and more solid understanding of that concept. So, what we've been trying to understand recently is how does p-evoke work within the C sharp framework. So C sharp, I want to be able to call a C library, and how do I actually get that to work? So you can do something called p-evoke, and let me make myself a little bit smaller. So we have code here, and we were able to get it to work. So essentially what we have is I have these functions, which is like to upper, sum array, and add. Now none of these um, are actually defined within my C sharp program. Let me make myself a little bit more small. There we go. So I have this add, sum array, and to upper right here, but if you look, they're defined as extern. So, okay, well, I defined them where? It's in my C program. So I have this C program here, and this is where they're actually declared, okay? So now what I'm trying to do is understand how the relationship between these two actually works and how you can do stuff like marshaling. So first step is just get it to be able to work. That's step number one. After you get it to work, then it's time to go in and actually investigate how is it working, why is it working, and continue to increase in complexity. So the first time we just got this little add to work. Then we went and understood it. Secondly, in the last video, we added these two, which require marshaling. Okay, and now in this video, we need to say, hey, how do we actually understand what marshaling is? What's going on? I know that it has something to do with getting the data types correct, but let's kind of go through this again. So what I'm going to do is just come here and I am going to say, okay, so I'm just going to copy this, paste it into here, and say that I'm a human, yes. Oops. And then copy this as well. Okay. Can you explain exactly what is going on here? Okay. So we'll let it do its thing, and then we might go line by line. We'll try to figure out where our misunderstandings are, how we can understand the marshaling a little bit better, and yeah, so we'll see what it is talking about. Hopefully it's not too much on the actual like code here. Like we don't care about that. We want to I should have said like focusing on marshaling and p-evoke. Okay, but I didn't do that. I might do that. So let me come back to here and let's look at these lines right here again, because what I'm trying to think about is, notice all three of these have the exact same DLL. Now, obviously, I know that this is not a DLL, but this is the Mac OS's version of the DLL files. So they have the same file, which makes sense because when I didn't mean to put a breakpoint there. When I have my C file, all three of these, functions are here within the C file. When I compile it into this DLL file right there, and then I paste it into the project. So it makes sense that I'm telling the compiler, my C sharp compiler, I should say, I'm telling the C sharp compiler, hey, look in this DLL. And they're all the same, even though they're different functions. Okay. calling convention we have here. We looked at that in the last video. And what calling convention is how is the stack actually processed? Like, how is memory processed? And there's certain different conventions, and both the C# and the C need to kind of agree on their calling convention, on how they're going to deal with data, memory specifically. Okay, so then public static extern. This is the C# portion of things. So I'm saying that, hey, there exists this int add right here, and we're just defining this function. Now this that I highlighted, that is the actual function which is in the C code. So int add and then int A, int B, int C come here, and we have int add, int A, int B, int C, okay? Now this export, that is a macro, we define it right there, to make things visible and to not scramble up. Wait, no, the scrambling was something else. But this export, let me move myself, was to make things visible in the DLL so that the compiler in my C# is able to go in and actually find what it's looking for, meaning the function. It's able to find this add. Okay, so this must match up with this, which it does. We're good. Okay. And one of the things that I need to pay attention to is int. So an int in C# matches an int in C. And so we don't need to worry about that. I think it was called blittable. It's a blittable type, meaning kind of like equivalent. Okay. Now I said, hey, I want to experiment, and I want non-blittable types. I want types that don't match. And so how do we do this? Okay, so that's kind of what we're doing here, which is what we're going to look at. Public static extern. Okay, that's just the C# declarations. Then we have a double. Okay, sum array. That's what the function is going to be called, sum array. So we have double sum array. Awesome. Now look at this. Constant. It's a double pointer at values. Okay. And then we have int, which is just not interesting. Okay. So now look at this. We have this in within brackets. We just say in. I don't know what that is. I'm going to investigate that pretty soon. Then we have double. We have a double array. And this one was not defined as a double array. It's a pointer to doubles. Now, are you... obviously, I understand that you are able to operate on a pointer very similar to how you are able to operate on an array. I get that. But as to my current understanding of how this p-evoke operates, the things, both the name and all of the parameters need to match exactly, which makes me wonder, like, okay, well, this is declared as a double pointer, constant double pointer. This one is just whatever this is. I don't know in what that is. And then a double array. Okay. And then this one is correct, or like what I would expect. And then we did one more thing, which is we have private static extern. Okay. No worries there. Void to upper. Void to upper, that's the same. We have a character pointer, so a char pointer called input. And then this one, we have something which is called int pointer. and then input. So that's kind of what I want to understand how we're doing. And then we have this Marshall here. I remember we have a Marshall there. And then unmanaged is also, I'm passing in this. So you see, that's kind of what I'm trying to experiment and play with today in this video. So let me take a sip of coffee and let's get started. All right, let's go. So I probably should have asked a better phrased question. Okay, so here, this is what we want to know. So declares the native sum array function. So native means within C#, that makes sense, yes. So brackets double, or bracket in double, okay, tells the marshaller this array is input only. Okay. The runtime pins the array in memory and passes in a double pointer. And then int length is passed in directly. Okay, so follow-up question number 1. Who is the marshaller? Who is the marshaller? And how does it know to pass in a double pointer and not just an array? I don't even know if this is phrased correctly, because array of doubles, is it equivalent to a double pointer? Array of doubles, which is actually what is declared in the C#. Okay. That's follow-up question number 1. We're probably going to have a lot more here. So here, it takes int pointer, a managed wrapper for a raw pointer. Why do I need int pointer input instead of just doing this? Okay. What actual... I don't want to ask what actually is the int pointer, because we actually looked it up here. Like, I asked that question wherever it is here. So I should have read this a little bit more last night, but I didn't. So yeah, that we can read through that as well. We don't need to generate it again. Okay. So now here, this is normal. This is normal. This is what we are curious about. Okay. So string s is equal to hello world is a managed UFT or UTF-16 string, immutable. Okay. So this line Marshall string to H global ANSI allocates unmanaged memory and copies the string as ANSI char pointer, returns an int pointer to that buffer. Oh my goodness. Okay. Well, can you go step by step exactly what happens in memory when we do the line show all variables and how and memory locations and how they are filled out and changed. Okay, so now we're doing the exact same thing, but we do have an exclamation mark here. Does it mention what the exclamation mark does? Okay, follow-up question number 4. So we're doing the same thing here, but what does the exclamation mark at the end do? Okay. And now I'm going to say number 5, I noticed, because we have here, this, where is it? This one, freeze unmanaged memories to avoid leaks. So I know that C# has garbage collection. And so now with unmanaged, we need to be aware of this garbage collection. That's actually very useful to know. So I noticed we need to free unmanaged memory. This implies that C#'s garbage collection does not automatically deal with it. Okay. Because it's getting a little bit long here, I'm going to press enter and then we'll go back up here. What did it say? Oh, thinking. Okay, so while it's doing that, it's going to be bouncing around and difficult to read, but every time it like does its output, it always bounces around and jumbles up where you're looking. Okay, so this is fine. We looked at that last time. This is fine. This is fine. Okay, so great. See my thing? Yeah, sure. What's this? Oh, that's kind of cool. Okay. Organizing my thoughts and creating a plan, explaining the DLL attributes. All right, I'm thinking about how to use double pointers for an array. It seems like. So this is Copilot itself, like talking back and forth to itself, because it says, wait, I need to think about using out or in-out attributes and the Marshall as option. Got it. Still working on these steps. Huh. Interesting. That's cool. We can see the thinking now. All right. Let's come up to here. All right. Marshaling and how arrays become pointers. So, who is the marshaller? The .NET interop marshaller is part of the runtime. Okay, so during the runtime, we have the marshaller. Okay, when a method is marked DLL import, which is what we're doing here, we're marking the method as DLL import. Yes. The runtime uses built-in rules. Okay, the runtime here uses built-in rules to convert managed arguments and returns their unmanaged equivalent during the call boundary. Okay. So is it the marshaler's responsibility to be able to pass these back and forth correctly? Okay. How it knows to pass in a double array as double pointer. Okay. An array parameter in a p invoke signature is treated as a continuous block of elements. Yes, that's correct. For blittable element types like double, the marshaler pins the managed array so it doesn't move it. Okay, so it pins it in memory and passes a pointer to the first element, that's normal, okay, to the native code. Okay, the the pointer is a double pointer. Like, yes, but they're defined differently. And so does it cause an error because the marshaler should say, oh, this was declared as a double, an array of doubles. Like, how does it know that it, maybe it's just auto, like, every time you pass in a double array, it does that operation? Possibly. The brackets in attribute tells the marshaler input only, so it won't copy data back after the call. Okay. Meaning I am not going to be changing the data in place. Okay. Okay. The marshaler copies the data from native memory back into the managed array after the call. If you omit both, the default, okay, is in. Why int pointer instead of char pointer? Managed strings are immutable. So managed, meaning C# code, or C# strings, are immutable. Passing a C# string directly would create a temporary native copy. Temporary meaning like ephemeral, okay? Native copy edits in native code wouldn't affect the original managed string. Okay. Also, the marshaler owns that temporary buffer's lifetime, not you. Unsafe pointers versus safe handlers. You can write a p invoke that takes unsafe pointers. So char pointer is unsafe, but that requires compiling with unsafe code and uses fixed pinning yourself. Okay. Lifetime immutability control. Using the int pointer with string to h global ANSI gives you explicit control over the allocation, mutation in native code. And freeing via free gives you, or if you want, in place string modification without manual allocation. Okay, so what happens in memory when we do this string to h global ANSI? Let's kind of look at that, and then maybe we can come back up to here and understand. Okay. So let's trace this line. We have this line right here. So assume S is equal to hello world. Awesome. So we have a string, which is a char pointer, and it is hello world. Manage string layout. Okay. So managed means in C#, string layout, object. A managed system.string lives on the managed heap, encoded as UTF-16. Each char is 2 bytes. Okay. So we have 2 bytes that live within the managed heap on the C# heap. Okay. So then fields. The string object holds a length and a character array payload. It's immutable and tracked by the GC. I don't know what GC is. So I just want to make sure that I can't change once instantiated. So obviously I'm still getting a little bit used to some of the C# I guess language things, and I don't use strings that often in C#, so I don't know that question actually. Like, if you declare a string, can you change it after? I'm not sure. You mentioned managed heap. Can you tell me the other other locations? Who owns the managed heap? Is it the runtime? Okay. And then what is UTF-16? Are there others? I'm guessing there's probably other like encoding mechanisms. And then the other one is, what do you mean tracked by the GC? Okay, allocation of unmanaged buffer. Unmanaged buffer. So, allocator. The string to H global ANSI uses the COM. Okay, task allocator. Task allocator. Equivalent. What is a task allocator? The H global heap to allocate unmanaged memory. Size. It computes the ANSI byte count for the string plus one of the null terminators. Okay, so it's just getting the size of the string and adding the null character. Okay, that's fine. So encoding and copying. The UTF-16 characters are converted to single byte ANSI. Best effort non-ASCII characters may be lossy. Okay, so we have this hello world, and each character is there, and notice each one is that is the 2 bytes, right? Okay, and then at the end we have that the null character. the null terminator. Okay, so return the pointer. The function returns the starting address of the unmanaged buffer as an int pointer. No pinning is needed because it's not in managed memory. Okay. I just want to make sure. When you say managed, you are meaning in C sharp. What exactly do you mean as managed? Okay. So now this free one releases the unmanaged allocation. If you skip this, you'll get a memory leak. Okay, yeah. The null forgiving operator. Oh, okay. Null forgiving is what that exclamation mark at. Where is it? Right. Where to go here? So we did a string and say Marshall and then pointer to string ANSI. Okay. And we're copying it into this variable. Okay, so we're taking the unmanaged, like, buffer. I think this is what they're meaning, the buffer. We're passing that. We got it back from this function. It was modified in place. And then we're doing this here to get it back into the managed, which means here. And then we can print it and we free the unmanaged buffer. Oh, I think I see what's kind of going on. I think I see what's going on. Let me take another couple seconds as a coffee break and then get back into this. All right, okay. I think I'm starting to see what's going on. Okay, so the exclamation mark after the expression in C sharp, null forgiving operator, it tells the compiler, I know this value isn't null, suppressing nullable reference warnings. Okay, so we're just going to guarantee that it's not null. Okay, that's kind of what it's telling. To suppress warnings. That makes sense. Okay, so here, Marshall Marshall pointer to string ANSI unmanaged asserts that the result isn't null. In practice, since it's safe to assert non-null. Returns null if the int pointer is 0. Since you just allocated it, it's safe to assert not null. Okay. Because we allocated it here, I think. But what if this was null? Okay. So, GC, we still don't know what GC is. Like, that's a question that we need to figure out. The garbage collector. Oh, is it garbage collector? Is that what it means? The garbage collector manages memory on the managed heap. Okay, so heap, if we remember back, we have the heap and the stack. Stack is where, like, normally if I do like, whatever, double total is equal to 0. So this is on the stack. But if we do dynamically allocated memory, such as like new, that's on the heap, okay? And so in C sharp, the garbage collector manages memory on the managed heap. That's what it's talking about with managed heap. Anything you allocate via Marshall, so H global or C task mem, lives in unmanaged memory and is invisible to the garbage collection. Okay, I'm starting to see. So we need to manage it actively. And that kind of makes sense why it would be called managed versus unmanaged. Okay. Okay. Ownership. If you allocate unmanaged memory, okay, you must free it. Similarly, if native code allocates memory and returns a pointer, you need a matching free function on the native side or use custom marshaling that calls the right deallocator. Okay. All right. Cool. So extra insights, alternative variants. So in place string without manual allocation. So we can do this DLL import, all of this, and then say charset is charset ANSI. Okay, I don't know. Anyways, come here. Let it do its thing. Okay. Okay, immutable strings and the managed heap. So immutable. Yes, in C Sharp, strings are immutable. Once you create a string, its contents can't be changed. Any modifications like to upper actually create a new string object with the new contents. This design makes strings thread safe and predictable. Okay, I see. So it's different than like Python. All right, that makes sense. Managed heap. In the memory region where the .NET runtime, the CLR, okay, so the .NET runtime allocates objects like strings, arrays, and class instances. So that's dynamic memory, that's on the heap. It's called managed because the garbage collector, GC, manages it, allocating, compacting, and freeing the memory automatically, so you don't need to worry about it. You don't need to do those frees and new and all of that. Awesome. Locations. So we have the stack, we have the unmanaged heap, we have the static data set, and we have registers. Okay. So let's kind of go in and look at each of those. So stack, each thread has its own stack for local variables and function calls. Okay. So when I'm reading this, one of the questions that I'm going to ask now is, I know that there are ways of doing multi-threaded programs, and you have to deal with all of the complexities of that. So you do like forking, and then you need to make sure that you do spin locks or mutexes or semaphores, right? Like all of these different methods to make sure that your critical sections are not having a race condition within them, all of that. So that's like one, I remember that we have to do it that way with multi-threading. But when we write a program, is it is there some magic on the back end that's making things multi-threaded, or do we always have to do it kind of actively? Okay. So that's a question I want to ask is multi-threaded, and I'm not going to write the entire thing yet. We'll write it once we want to ask the follow-up. So unmanaged heap, memory allocated outside the CLR, outside of the runtime, okay? Example is malloc in C, or Marshall and then allocate H global in C sharp. The garbage collector doesn't track this, okay? So that's unmanaged. Static data segment for global and static variables in native code, okay? And then temporary storage inside the CPU during execution. Okay, yeah, that's just the registers. Who owns the managed heap? The .NET runtime. So the CLR owns and controls it. Your code never directly allocates or frees memory there. The runtime does it for you. Awesome. UTF-16. It's a character encoding where each character represents 16 bits or 2 bytes, right? 8 and 8. Each byte is 8 bits. Okay. So we're just saying like, oh hey, each letter we're going to represent it with 16. Okay, so C# strings are stored internally as UTF-16. Other encodings are ASCII. Okay, yeah, there we go. Is a 7-bit encoding for basic English characters. Yeah, so we've heard of ASCII. And so UTF-16 is just another type of encoding for characters. We have UTF-8, so variable length encoding, 1 to 4 bytes per character, widely used on the web. Okay. UTF-32 is fixed 4 bytes per character. Different encodings balance memory usage and compactability. Okay, so tracked by the GC. Every object on the managed heap is registered with the garbage collector. The garbage collector knows which objects are still reachable, referenced by your code. When an object is no longer referenced, okay, the garbage collector eventually frees it. So like dangling pointers, essentially. It's looking for those dangling pointers that we are no longer like have access to anymore. That's why you don't call free in C#. Second question is I'm just curious, like, is there a way to stop the garbage collector from deallocating, like force it to say like, hey, leave this in memory? I don't know exactly why you would want to do that at this point, but there might be some use case, and I'm just curious, like, can you do that? Okay. What managed means? Means it's time. All right. So what does managed mean? It's under the supervision of the .NET runtime. Yep. Garbage collection, type safety, exception handling, security checks, interop services. Okay. Unmanaged is code that directly runs on the operating system without the .NET runtime supervision. So this is the DLLs and SO, that's Linux right there. dylib, that's the Mac OS version of DLLs. OS APIs, so like if we are accessing some hardware driver on the system itself, whatever that would be, like input, right? The user is typing in, and so you have to call the operating system's APIs to be able to get that data to and from things. So that's unmanaged. Memory you allocate with malloc or Marshall allocate, okay? So when I say managed, I mean objects and code that live in the CLR world. Okay. And likewise, unmanaged is the opposite. So let's ask this multi-threading one. Okay, so I want to understand about T-threaded more. If I have a program in C#, does it automatically utilize multiple threads? I know that there are ways to actively do dethreading with fork, what was it? Locks and semaphores. Okay. Do I always need to use those active methods? Okay. Okay. Let's let it think and take some more coffee. Okay. So, first off, we're talking about multi-threading. Yeah. Okay. Does C# program automatically use multiple threads? So by default, a simple console program runs on one thread. Okay, yep. However, .NET Runtime itself uses background threads internally. Okay. For example, garbage collector runs on its own thread. Okay. And asynchronous I/O, like file or network operations, often use threaded pool threads behind the scene. Okay. Threaded pool threads. That sounds kind of cool. Obviously, we're going to look that up. Okay. So even if you don't explicitly create threads, your program may still benefit from concurrency in the runtime. So when do you need to actively use multi-threading? If you want your own code and if you want your own code to run tasks in parallel, compute two things at once, or the UI responsive while doing heavy work, you need to explicitly use threads. Okay, so now C# does offer this. Okay. Can't remember which. I think we used multi-threading within C. Yeah, it wasn't C++. But I think C, C+, and apparently now C# also have this multi-threading capability. I believe Python was like pseudo multi-threaded, and I don't mean pseudo as in like the Linux command sudo. I mean like PSEUDO, like it's not real, but it kind of simulates multi-threading. Okay, so instead you use higher level abstractions. Okay, so in C# you rarely use primitives like thread and lock or semaphores directly. Instead, you use higher level abstractions. Okay, so task.run. I have seen this. I have seen task.run. I didn't know that that was multi-threaded. I'm actually very glad that I followed up on my curiosity there because that's something that I've seen before, but I didn't know that it was a connection to multi-threading. Async. Okay, async, just like in Java we have async. So async awaits JavaScript right there, I think, for asynchronous programming without manually managing threads. So I didn't know that async was a threaded thing. Thread pools, managed pool of worker threads. Okay. Locks and semaphores are still important when you share mutable state across threads, but many modern patterns reduce the need for manual synchronization. Okay, so we're going to ask, I'm not going to ask this one yet, actually. I'm going to ask it more follow-up questions relating to the multi-threading. And I know that we're kind of getting away from what we were trying to do, but I feel like we got on a interesting path, and then we'll try to get ourselves back on in the future. Okay, so stopping the garbage collector from deallocating. You can stop the garbage collection from freeing memory? No, you cannot. So this was a question. Can you stop? And the answer is no. You cannot globally turn off garbage collection. I was meaning like for one specific thing. It's a core part of the runtime, but you can influence it in specific ways. So pinning an object using GC handle allocate here prevents the garbage collection from moving or collecting the object. Useful when passing managed code to unmanaged code that expects a stable pointer. Okay? You must free it later. That makes sense? So let's see. Suppressing finalization. So GC dot suppress finalize, and then the object tells the garbage collector not to call the finalizer for an object. This doesn't prevent collection, but it skips the finalizer step. Then we can do garbage collection dot keep alive. Ensures the object is considered in use until that point in code. Preventing premature collection. Okay. Okay. Well, can you tell me more about how we can use those higher level multi-threaded concepts? Where was it? These three. This one, async await, and thread pools. Okay, tell me what they are and how they actually implement with different threads. Okay. All right, so in C#, the task parallel library, okay, async await and thread pool are higher level abstractions that let you run code concurrently without manually creating and managing threads. They all rely on the thread pool under the hood. Okay, so thread pool kind of underlies all of them. So, but each provide different levels of control and convenience. Awesome. So, a set of let's see, task parallel library, TPL. This is a set of APIs, system threading task, okay, that simplify parallel programming. You work with task objects instead of raw threads. So we have an object called task. How it works, you create a task, task.run, and then pass a function in. The runtime schedules them on the thread pool. TPL handles partitioning work, balancing load across CPU cores, cancellation, and exceptions. Okay. So threads used. Tasks don't create new threads by default. They reuse thread pool threads. This avoids the overhead of constantly creating and destroying threads, okay? So task.run, and then this callback. Is that a callback? No, that's a anonymous function right there. And then another anonymous function for task 2, and then task.wait all, and then we can do, that's like what, join? Like thread.join or whatever. So then we wait for both of them to finish. Okay, so async await. We've used this in both Java and JavaScript. And it was kind of like you have a promise. So I didn't recognize it as multi-threading. It was just something like a promise that I was waiting for it to get fulfilled, and once it's fulfilled, then uh, things work out. But now, even saying that, it kind of makes me recognize that, okay, well, what was probably going on is we have a thread, multiple threads, and I put the thread to sleep or something like this while it's waiting, and other code can be executed. Okay, so an async method returns a task right here. Okay, await pauses execution until the task completes without blocking the thread. So for IO bound work, like file or network calls, async await doesn't necessarily spin up new threads. Instead, it frees the current thread to do other work until the IO finishes. I think that's that pool that it's talking about. So you say, hey, I don't worry about me. You can do something else, and it gives itself back over to the runtime. The runtime allocates a different task to that thread. Okay. So threads used. For CPU bound work, async method still uses thread pool threads. IO bound work, async await often uses OS level async. Okay. So in C#, we have async task string, fetch data async. Okay. And then we're awaiting this. Yeah. All right, thread pool. What is it? A pool of workers managed by the CLR, the runtime. Threads are created once and reused for multiple tasks. You queue work items, threadpool.queue user work item, and the pool assigns them to available threads. The pool automatically grows in strings based on demand. Thread used, actual OS threads, but managed by the runtime. Threadpool.queue user worker and that. Okay. How everything is fit together. So thread pools, the foundation, manages actual threads. The TPL builds on thread pool, giving you task objects, cancellation and exception handling, and parallel loops. Okay. I've also heard of like cancellation tokens, but I didn't know exactly what was going on. So maybe that's something important. Async await builds on TPL task, making asynchronous code easier to write and read. Yeah, okay. So thread pool is the raw threads managed by the runtime. TPL, a structured task scheduled on thread pools. Async await, language sugar over tasks, especially for IO. Okay, awesome. So I'm going to take a little bit of a break. We were kind of learning a fair amount of different ideas, but that's kind of what this series is about, is trying to go and just explore different things that we are unfamiliar with and trying to improve ourselves as engineers, try to get a better understanding of many of the different aspects. So I think it was a very successful video. I learned a lot. Hopefully you guys did too. I will be back pretty soon. I'm going to make another video today. I'm going to make more videos. So if you want to subscribe, that would be awesome. I would love to have you around, and hope everyone is having a good day. My name is Timothy Lee Grant, and I'll see you guys soon.